Okay, question 8. If a cube has sides of length 5, what is the maximum distance possible between 2 points located on the cube's surface? All right, so I like to start out by drawing the cube. All right, it's not a very good cube, but just pretend that all of these sides are the same length. So each of these sides is equal to 5, right? So 5 up, 5 out, and 5 back. Okay, so what 2 points are we looking at? So the 2 points that will be located farthest from each other will be in the opposite corners. So if I choose the front left bottom corner over here, well, the farthest point on that, the farthest point from this point on the cube surface will be in the top right back corner, right? And so that's the same distance from, say, this back corner to this corner, or this corner down to hit this corner. We're just going to choose one, right? So these are the points that are furthest away from each other. So there are multiple ways to solve this, but I think the easiest is to use our distance formula. So so d is equal to the square root of, well, we have x2 minus x1 squared plus y2 minus y1 squared. And for this case, we're going to add a third dimension, z2 minus z1 squared. Okay, so what the heck am I talking about? How am I going to solve this? Well, so this cube is in 3 dimensions. What I'm going to do is take this corner, and I want to put it, or maybe it's easier to see from this corner. I'm going to take this corner and then put it in an xyz plane, right? So I'm going to call that point 0, 0, 0 at the origin, okay? And then I'm going to compare it to this point up here. So where would this point be? Well, let's call this our x-axis. Let's call this our y-axis. We'll call this our z-axis. So for x, we're going from 0. We're going to go out 5. Okay, so this will be 5. Our y-axis, we're also going out again this way, 5. And then for the z-axis, so we've gone out here, we've gone over here. Now we're to go back up to this point, we're going to go up 5. So 5, 5, 5. Okay, so we have 0, 0, 0. That's going to be our y1, z1. And then 5, 5, 5. So this will be x2, y2, z2. And now we're just going to plug that into our distance formula. So, okay, this is the 3-dimensional distance formula. So we have x2 minus x1, that's 5 minus 0 squared. And you'll notice that these are all the same. So that's going to be 5 minus 0 again, plus 5 minus 0 again. Oh, sorry, these are both squared. So we're going to get 25 plus 25 plus 25. And we're going to simplify that down to get 25 plus 25, that's square root of 75. And if you do that, well, you can take what? That's really equal to the square root of 25 times the square root of 3. And so we can take this 25 out as a 5, multiplied by the square root of 3. And so we find that this is the distance, which is answer E.